Hello and welcome once again to Civil Engineering Today. I'm AnaCristina Fragoso.
And I'm Brockman, and today we have a very special guest for you. We have from Massachusetts Institute of Technology, we have Professor Joe Sussman, and he is from the Civil Engineering Department and the Systems Engineering Department. So Civil and Environmental Engineering and the
Engineering Systems.
And Engineering Systems Department.
Welcome,
Correct.
Professor
Welcome.
Sussman.
Thank you. It's a pleasure to be here.
So one of the big things that's going on in society today is we're starting to look at things as more of systems, and that's really one of the things that really amazes me about what you do. Sometimes, like, you know, if we look at a problem, it's way more complex and there's so much more involved than what it seems. How do you even begin to approach some of these really complicated problems that you've been coming upon?
That's an excellent question. We're dealing with a lot of what I like to call critical contemporary issues. We have issues of global warming and air pollution and energy crises and what have you, mobility. And one has to think in a very systems-oriented way to begin to develop an approach. So I'm a specialist in transportation, but I like to think of myself as someone who deals with transportation as something that's integrated with these other issues. One can't make decisions about transportation without worrying about the environment, without worrying about global climate change, without worrying about where the energy is going to come from to run the transportation system. So thinking, I like to discuss it as thinking horizontally, cutting across the silos and trying to create integrated solutions to the kinds of issues we deal with.
One of the big words I hear a lot is intelligent transportation systems. What is that?
So I've actually done a lot of work in what we call ITS, Intelligent Transportation Systems. It began here in the United States in the late 1980s, and in fact, back then we were behind both the Japanese and the Western Europeans. At this point, I think we've largely caught up, and in short, the idea is to use advanced technology to enhance, in particular, urban transportation and public transportation. So the notion here is that you can sense where vehicles are on the infrastructure in real time, so you understand what the state of your network is, and you can make decisions about how to operate the network in such a way as to make it as efficient as it possibly can be. We can provide route instructions to individual drivers. Here's how you get from here to there, and here's where you probably ought to deviate, because as it was coming over to the studio, Mass Ave is very congested. Right. Let's figure out for you another way to do it. So ITS can have some profound effects on the operation of the transportation systems. And here in Massachusetts, we use it every day in the sense of fast lane or easy pass. When you go through a toll and it's automatically, you go through at speed and it's automatically debited from the gizmo you have in your car, that's ITS in its form. And you can think very imaginatively about how to use that kind of technology. There's this concept that we call road pricing or congestion pricing. Yes. So once you have the ability to debit your electronic money as you go through a toll, you also have the ability to change the price. That would be very hard to do. You can't call up the toll taker and say, well, we just changed it from $1 to $2, start collecting $2. But if you're doing it with electronics, you can do it. And the notion here is to try and build incentives for people to, for example, travel at off-peak times. In some sense, if one thinks about the transportation network, the highway network, we're used to driving in congested circumstances because we all like to drive at the same time. We go to work in the morning, we come home at night, and so on and so forth. But if you looked at it over the course of 24 hours, you'd see there's an awful lot of uncongested, unused capacity. So if you can create incentives for people to drive other than at the peak hour, by, for example, charging them less if they're willing to go an hour or two early or an hour or two late. You can make much more effective use of the infrastructure you've already bought and paid for.
That's me. I'm like leaving at 4 in the morning to beat the traffic.
I see.
But this makes me think. I know there was some talk a while back about putting some sort of a sensor system into, like, say, an inspection system. So you not only were in real time, kept track of while you were on the network system, passing through tolls. But that would also be, and I think this is a good thing, given hopefully people are going to start buying more and more electronic cars, and you're going to see less revenue from gas tax. We can, based on how much of the infrastructure they're using, they pay the taxes on that.
Yeah, it's an excellent point, and I think it's the wave of the future.
I agree.
It's already being done in experimental ways out in communities like Portland, Oregon.
Oh, really?
Where they have the
I
idea.
didn't know that.
They have the idea of again, what we call road pricing, and you're quite right. As cars become more fuel efficient, if we start using exotic fuels, electric cars, hybrid cars, the money that's collected from the gas tax is going to go down, 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 and our ability to fund
Cost of
infrastructure.
materials not.
Right. The ability to fund conventional infrastructure is going to go down substantially. The trust fund, if you want to be alarmist, you say the trust fund, the highway trust fund is bankrupt. It's not quite, but it's getting there. So the idea is we have to come up with a different way of funding transportation improvements, and you're exactly right. The notion here, in principle, is everybody pays for every road you drive on.
And I think you should.
Short of your own driveway, presumably. Yeah. And you pay as a function of the time of day you're choosing to drive. You pay as a function of the kind of car you're driving. For example, a less polluting car, you'd pay less. A heavier car, a lighter car, you'd have differential prices. So you're creating all kinds of incentives, and people have to start to recognize this isn't a free good that people have to pay in order to make use of it. The classic social science idea is called the tragedy of the commons. If something is free, if all the farmers are having their sheep graze on the town green, no one farmer has the incentive to have his sheep not eat as much grass. Everyone's eating the grass, but it's free, so it's infinitely expensive to everybody, and it's the same thing in highway transportation.
No, I mean, I'm really glad to hear you say that, because I heard about it and then it seemed to kind of die off. You don't hear about it too often. But I mean, is there any way, I know of course there's lots of liability issues still being worked out, but something like the Google driverless car, I know that they were basing that idea on the fact that there would be some sort of real-time.
What is it?
The driverless cars, you haven't heard about it?
Google, no.
Well, they've just gotten permission, I think, to finally start experimenting in public spaces. But it's basically the car is navigated in real time via a network. The
sensors on the car are quite sophisticated, and one will see this in an experimental phase. I'm not sure we're going to see it anytime soon.
Darn.
Where you're going to be able to sit in the back seat and let your car take you to work. I think
that would be great. Nobody could speed. Nobody could cut you off. It'd be great.
Well, especially for Boston, we'd have to have a special Google driverless car for Boston, given our reputation for driving in this part of the world. My grad students come from all over the country and all over the world, in fact, and they are stunned by the fact that we tend to view traffic signals as advisory.
Yes.
I mean,
They're not?
No, they're not. You should really.
The one thing you know when you run that red light is if you look in your rearview mirror, there's going to be someone still right behind you.
I know. That actually amazes me, how many people do that. It's amazing. I remember that from transportation class, just counting how many cars would go after the light turned.
It's really quite remarkable.
But back to this technology. I really like the idea of it, and your ideas about funding. I mean, can you expound a little bit more on funding, because we're in a climate. I know it's an election year, so it seems even more so.
You hear more talk of infrastructure funding actually.
Right.
This
There's
year,
a lot more fighting
will it follow through?
about budget cutting and whatnot. And I think here, you know, we're lucky to have somewhat newer roads considering the amount of, when you go down south, they don't have anywhere near as much inclement weather ruining the roads.
Yeah, frost
for
heaves in
instance.
Atlanta are not a big problem.
Yes, the cost of like our urban infrastructure is definitely, I mean, I don't know any percentages, you probably know more than I do, but it seems to me that it would be significantly more money to maintain than somewhere where there's a lot less driving.
Maintenance is a function of the initial construction, how much was spent on the infrastructure to begin with. If you do a better job on initial construction, maintenance costs will tend to be less, but people will start cutting corners sometimes because the bucks aren't there. So they may not build up to standard, which is sort of creating a deficit in the future, a problem in the future, because the maintenance becomes that much more expensive. So there are these issues, and of course, the politicians love to clip a ribbon on a brand new highway, a brand new bridge.
Getting there takes years.
But getting the money to maintain it, I mean, no one clips a ribbon, snips a ribbon on a maintenance project.
Right.
No.
Right.
It's really interesting to try to think through how the world is going to change in this context, because I tell my students that having the right technology is important, but it's far from the only piece of the problem. That one has to worry about organizational and institutional and political issues as well. And the idea is, for example, with a technology like ITS, we've largely solved the problem now because we've been at it a while, but in the early years of ITS, you go to state highway departments, you go to large city transportation departments, and you talk to people, chief engineer, whoever, who had made his or her reputation by properly constructing and maintaining roads. And in we come and we say, well, you know, there's another solution. We can make more effective use of the capacity we already have with advanced technologies in the way I was describing before, by pricing the infrastructure in a different way. And there's a natural resistance to that.
Really?
What people say, do I really want to do that? You know, we're doing okay as it is. And the idea that we're going to enhance capacity without building new infrastructure can be viewed as professionally threatening. And yes, we ran into this time and again.
Wow.
So as I say, now we've largely, I think, gotten the credibility where people recognize that's part of the job. That's part of the job of a civil engineer, to recognize that there are those kinds of aspects that new technologies can be effectively used and in a complementary way to the conventional solutions of building more infrastructure. But it requires the change to an organizational culture. And culture doesn't change so fast.
That's true.
It's on
Seems like it doesn't change at
25,
all.
30-year cycles. It takes a long time for the students coming out of school at places like MIT, at places all around the country, who have been educated to think in terms of these kinds of, say, ITS-type solutions. It takes a long time for them to get into the organization and move up to a position of authority where it becomes the proper way to do it. We've spent a lot of time worrying about re-education of senior people in the civil profession. That is, to take people who are already quite senior and already quite accomplished and bring them in and say, let's take a look at some innovative things that we can do to kind of finesse the situation of having to wait for the 25-year-olds to become 45-year-olds and be in a position of authority. So it's a challenge for the educational system as well. It's and we more and more as educators recognize that we have a responsibility and a market that goes well beyond 18 to 20-year-old undergraduates or 22 to 25-year-old grad students, that we have to think of providing programs for people who are much more senior.
I absolutely agree, and I don't think it's just our industry. Just even on a side note, I think technology is changing so rapidly that I think it's a good time to revisit for a lot of people with experience to revisit the new technology and recognize where it could best be applied.
That's exactly right. I think the kinds of decisions we have to make about how to advance our institutions is really a partnership of the profession and the academic community. There's often been sometimes a tension between the profession and the academic community. A student will come out and the practicing professional in a consulting firm says, well, you just got a bachelor's degree from wherever you got it, and you should be in a position to, just start being 100% productive on day one.
Yeah.
And I think it's an unrealistic expectation, and I think it's a counterproductive expectation. We've always taken the position that yes, we have some fundamental responsibilities to educate our students and to teach them the basics and teach them the underpinnings. But they have to learn a lot while they're in professional practice as well. I've done a lot of writing about this idea called the new transportation professional, recognizing that people who are going to be talented leaders in the field of transportation have to have not only deep expertise in some specialty, but also broad understanding of the various issues. And I talk about the T-shaped professional. It's just dumb luck that T happens to be the first letter in transportation. but basically the vertical bar in the T is some in-depth expertise, let's say in technology, let's say in mathematical modeling, whatever it may be. But the horizontal bar recognizes that new transportation professional has to have expertise in technology, in the traditional and advanced sense. They have to have expertise taking a step back and thinking about transportation as a system, not simply thinking of it as one link from here to there, but rather as a networked system that interacts with the environment, with the economic development system, with the...
It seems like that's like so many variables.
Right.
What is there software? I mean, or is that in development phase? I mean,
think
is
it's-
someone sitting there on MathCAD like figuring out?
No.
This is a real person we're talking about.
I think, and just to finish, you've got the focus on technology, the focus on systems, and also the focus on institutions, on knowing how things work and how one has to work within an organizational context to make things happen. If you're going to improve the use of technology in transportation, it's not enough for MIT or Berkeley or Texas or UMass to wave their hands and say, gee, you guys got to get on the ball. We have this great new set of technologies.
Right.
It has to be recognized as an institutional change issue. So the T-shaped professional is a concept that we strive for. We're always going forward toward it. It's sort of like the Holy Grail. You may never quite get there. But people who are going to lead in the field of transportation are going to have those sets of expertise. They have to have those three foundational elements to really understand how the system fits together and how decisions have to be made that are cognizant of global climate change, or that are cognizant of noise pollution, that are cognizant of all the kinds of impacts that transportation has. Obviously, transportation is a very good thing.
Yes.
One can't have a functioning society without the transportation system. It enables economic growth, it enables social interchange, it's fundamental to society. But we're blind if we don't recognize that it doesn't exactly tiptoe into your community, that it has an impact, and we have a professional responsibility, I think, to worry about those kinds of impacts.
So do you think that this is something that you can limit to? I mean, it doesn't sound like it's something that fits into definitely not a 4-year education. Does this start earlier? Maybe start even middle school, high school, getting this. At least the bar, the straight bar, the T broadened, and having programs that earlier earlier grades that just teach you how society works?
To start to think about how one, we call it systems thinking, how one thinks in an integrated way. I use the analogy of horizontal and vertical. Typically, we like to drill down really deeply and understand the physics at the nano level.
Right,
And of course, there's value in that. But one also has to think about think horizontally, how one thinks in an integrative fashion about how all these systems fit together. We have a lot of debate in academia about, it's interesting you raised the idea of doing it in grade school or high school. We have a lot of debate in academia about when you actually introduce these kinds of systems ideas. So at MIT, I've been an advocate of teaching these systems ideas very early, in a freshman class, for example, or a sophomore class. And frankly, you get a lot of pushback from colleagues in if you will, traditional departments, who will say, look, Joe, we understand this is important. Obviously, to be in a leadership role, we're going to have to teach it, but not now. We want our students to get a solid grounding in civil engineering, in environmental engineering, in electrical engineering, whatever it is. And then when they get perhaps to graduate school, we can start that kind of integrative teaching. And I worry a lot about that. I don't agree with that as a philosophy, but some very learned and distinguished colleagues of mine will argue me to death on that question. So the notion of breaking down these intellectual silos that we deal with earlier rather than later is important. We get these students who come to MIT. They're 18 years old. We're blessed with having a very talented base of students who come to us. And they're very idealistic. They want to change the world. They want to work on global climate change. They want to work on these, what I called before, critical contemporary issues, which we know are very integrative. And you're not going to solve it in civil engineering or in economics or in management or in physics.
I agree.
It's all of the above. So in they come. And they say, gee, now we're finally out of high school and all the constraints of high school. Now we're in college. We want to start dealing with these critical contemporary issues. And what a lot of schools say is, well, first you got to learn a lot of stuff.
Yeah, the curriculum's heavy.
Right, and first you got to learn your math and you got to learn your physics, and we don't want to distract you by thinking integratively, horizontally, because you're not quite ready for that. Well, I think they're very ready for that.
So at that, we're down to the final minutes of the show.
Oh no!
And
I want to
follow. I know, but I want to follow on this. That even though the school curriculum may hold to that, we have some after-school programs and things that we do, and we're hoping that the whole community, all the STEM-related, the science, technology, engineering, and mathematics fields, will try to encourage students to think more broadly. And we have activities even coming up this summer. We'll be at the West End Children's Festival. That's coming up. I wish I knew the date, but it's somewhere around August.
They can go to
20th.
engineeringfuture.org.
Go to engineeringfuture.org. But we have registration for the Future City competition going on right now, grade 6, 7, and 8, and pretty soon the Model Bridge contest that we run and a whole bunch of other activities will all be on a roll. And activities like this, these are all to encourage students to think more broadly and look at the more global community. And Professor
I think
Joe
Future City is
Sussman,
very good at that.
I think so too. Future City.
But
should
to
all get
recognize, are we still have a few moments, or we're
last minute.
Okay. But we need to teach the students, for example, that civil engineering is more than designing a bridge.
Right.
Yes.
You've got to think in a systemic way. How does that bridge fit into the transportation network? How does that bridge fit into other societal concerns? Is the money spent on that bridge better than housing for the elderly or whatever it may be?
Right, exactly.
So thinking systemically is the key answer.
I totally
We
agree.
would love to have you come back on. I actually have like 1,000 new questions
me
I want to
too.
ask just on the transportation system. So we'd love it if you'd come back at some point, but unfortunately we do have to kind of
No,
wrap
I'd
up.
be delighted.
Thank you very much.
Yes,
I've
and thank you
enjoyed it.
so
Thank
much.
you.
You were
Right.
And
great.
everybody, thank you for tuning in,
Yep.
and we'll see you in the next
month.
episode.
Thank you.
Thank you.